November 1944. A German patrol moves through the darkness along a forest trail in the Hürtgen forest. 5 soldiers, single file, advancing toward American positions about 400 meters ahead. The lead soldier's boot strikes a horizontal length of cord positioned roughly 15 centimeters above the ground, stretched between 2 trees, ankle height. The cord is fishing line, about 0.4 millimeters in diameter, nearly invisible in the darkness. Chosen specifically because it gives almost no warning before tension breaks. The line connects to a friction pull igniter attached to an American Mk2 fragmentation grenade. The grenade is suspended at chest height from an overhead branch by another cord. The tug on the tripwire pulls the igniter pin. Fuse delay, 4 to 5 seconds. The patrol has about 3 seconds to understand what happened before the grenade detonates. It explodes at head level, 2 meters above the trail, positioned deliberately to maximize fragmentation across the patrol's formation. The blast kills 3 soldiers immediately, wounds the remaining 2. The device costs nothing beyond a grenade and 2 meters of cord. It required about 15 minutes to emplace by 1 soldier with basic training. It functioned exactly as designed, killing multiple enemy personnel without the defender being present or exposed to return fire. American and Allied forces in 1944 and 1945 faced a defensive problem in forests and urban terrain. German patrols, infiltration, night movement. Maintaining constant alert sentries was exhausting. Positions could be bypassed. Intelligence gathered unnoticed. What defenders needed were passive mechanisms, something that could detect movement, engage automatically, work in darkness and bad weather, and alert friendly forces. The tripwire grenade trap was the simplest solution. 1 grenade, 1 wire, both sensor and weapon. Construction was straightforward. A hand grenade, tripwire cord, pull wing igniter, or direct pin extraction. Suspension system to position the grenade at the optimal height. The wire stretched across the likely approaches. Ankle or knee height. Fishing line preferred, hard to see, strong enough to pull. Anchored tightly to trees or stakes. The grenade was suspended above the trail. Height critical. Too low, fragments lost to the ground. Too high, fragments pass over crouched personnel. Optimal height, 1.5 to 2 meters, chest and head level. Activation varied. Simplest method, a tripwire attached directly to the pull ring. Contact pulls the ring. Pin withdraws. Striker released. Fuse ignites. 4 to 5 seconds. More sophisticated method, dedicated friction igniter, spring-loaded striker, pull triggers percussion cap, more reliable, more flexible placement. Fragmentation effect was significantly greater when suspended. An Mk2 grenade, about 57 grams of TNT, fragmented into hundreds of steel pieces. Initial velocities around 1,200 meters per second. Lethal range to roughly 30 meters. At ground level, half the fragments strike Earth immediately. Lost. At 2 meters height, fragments disperse radially. Minimal ground interference. Testing showed suspended grenades produced roughly 85% more casualties in simulated formations than ground-level detonations. Operational use expanded in Italy, then in Northwest Europe. Hürtgen Forest, Ardennes, Vosges. Placed along patrol routes, around defensive perimeters, doctrine recommended overlapping fields, 3 to 5 traps, 20 to 50 meters apart. Force patrols to either accept casualties or spend time disarming, time during which they were exposed. German counter-tactics developed. Advance slowly, probe ahead with poles. Effective in daylight, difficult at night. Illumination flares revealed wires, but revealed patrols too. Some units sent a single man ahead, accepting that he might trigger a trap, preserving the main group. Reduced casualties per device, increased overall losses, undermined morale. The psychological effect was substantial, every step uncertain, every branch suspicious. All sides used similar devices. German steel hand grenades suspended by a handle, Japanese cluster traps in the Pacific, Soviet urban tripwires in rubble. British training manuals documented technique. Universality suggests optimal resource use. Simple, effective, replicable. Limitations existed. Friendly vulnerability. Traps could not distinguish friend from foe. Areas required for mapping. Communication essential. Still, friendly casualties occurred. The weather affected the tension. Rain loosened lines. Wind triggered devices prematurely. Civilians occasionally triggered traps, politically troubling, morally complex. Accepted nonetheless. Post-war analysis estimated 7 to 12% of German patrol casualties in heavily trapped Hurtgen sectors were caused by tripwire grenades. Significant for a passive device. Psychological impact. German soldiers ranked traps among the most feared hazards, above snipers, comparable to artillery in stress. Strategic effect far beyond material cost. The German patrol that triggered the device in November 1944 was one of hundreds. The soldiers never saw the device, never saw the soldier who placed it, never had a chance to return fire. The rope and grenade were emplaced by an American soldier whose name does not appear in any after-action report. He may never have known if it functioned, because successful booby traps kill quietly in darkness and are discovered only when patrols fail to return or when survivors report contact.